All right, let's talk about Cursor. It's this AI native code editor that, well, you've probably heard about it. It's been taking the developer world by storm, and it promises a whole new way of coding, faster, more intuitive. But, and there's always a but, right? That speed might come with a hidden price. Yeah, an editor that writes code the way you think. That's the big idea here. The goal isn't just to help you out a little bit. It's to become a seamless part of your own thought process, to get rid of all that friction that pulls you out of your flow state. It's a really powerful promise, but the big question is, can it actually deliver? So, what is this thing that has everyone so hyped? Let's dive into the promise of Cursor and see what makes it a so-called AI native editor from the ground up. Okay, first off, the way they built this was pretty clever. It's a fork of VS Code, which is a huge deal. It means you can bring everything with you, all your extensions, your themes, your key bindings, with just one click. So getting started is completely painless. But that familiar setup, that's just the beginning. You might be thinking, well, how is this different from GitHub Copilot? And that's a fair question. The big difference is that Copilot is a plugin in your editor, while Cursor is an entire editor built around the AI. And that leads to this huge advantage, project understanding. Cursor can read your whole code base, not just the file you're in. That deep context is a total game changer. And with that deep context, you get some seriously cool features. I mean, you can just ask it plain English questions about your entire project. Hit Command-K, and boom, you're refactoring or generating code right there without breaking your flow. And that's not even the wild stuff. You've got Composer for making changes across a bunch of files at once, and even an agent mode that can just run commands and fix stuff for you. It's pretty wild. And yeah, developers are definitely paying attention. You can see it right here in this chart. The adoption of those agentic features, the ones where the AI is doing stuff on its own, it just skyrocketed. This thing is not a niche toy. It's becoming a major player. But when you have that many people using a tool, you start to get data. And that data, well, it starts to paint a much more interesting and complicated picture. So we've heard all the good stuff, now for the reality check. Because a big study out of Carnegie Mellon decided to see if all these amazing productivity claims actually hold up in the real world. Researchers at Carnegie Mellon published a paper, they called it Strudel, which is kind of funny, and it's basically the first big, serious look at how these AI assistants really impact open source projects. They didn't just take the marketing hype at face value, they dug into hundreds of repositories to see what was really going on. So here's the theory they were working with. The AI gives you this awesome burst of speed, right? Your velocity goes way up. But it might have some side effects, like making your code more complex or generating more warnings. Over time, that adds up to technical debt, which then starts to slow you down, creating this feedback loop that kind of eats away at that initial speed boost. So, was their theory right? Well, the data showed that yes, you get a massive surge in development velocity when you first start using it. But, and this is the key takeaway, that surge doesn't last. It's temporary. Just look at this chart of lines added from the study. In that first month, developers are just crushing it. We're talking a 3 to 5 times increase in how much code they're adding. But then look what happens. Just a couple of months later, poof, it's gone. The output is right back to where it started. So what gives? Why does the magic just stop? Well, that brings us to the hidden cost of all that speed, the price you pay. And it's not about money, it's a debt of complexity. This right here, this tells the whole story in one image. On the left, you see the speed boost, up and then right back down. But on the right, you see code complexity. It goes up and it just stays there. The speed is temporary, but the complexity it can create, that's persistent. And let's get specific. We're talking about a 30% permanent increase in static analysis warnings. All those little automated red flags for potential bugs and messy code. They go up and they don't come back down. And maybe even worse, overall code complexity jumped by a whopping 41%. And again, it stayed there. The code being generated was just harder to read, harder to understand, and ultimately harder to maintain. So what kind of debt are we talking about? Well, the study found big jumps in things like inconsistent naming, bad code hygiene, commented out code, unused variables, plus just general style and complexity problems. Basically, the AI was acting like a fire hose for code, but it wasn't always clean, well-crafted code. And here's the punchline. The paper makes a direct connection. All this new technical debt is exactly what causes the slowdown later on. It's not just about having ugly code. No, this is a real problem. The very complexity the AI introduces becomes a drag on the project, slowing everything down and completely wiping out those early gains. Okay, so does this mean Cursor is a bad tool? No, not at all. It's an incredibly powerful tool. But like any powerful tool, you have to know how to use it right. It takes discipline. So that leads us to the path forward. How do we get all that speed without drowning in complexity? Well, your first line of defense is a feature that's built right into Cursor itself, a file called .cursor rules. The best way to think about it is like an instruction manual that you give to the AI. You can lay out your project's coding style, its structure, and all your best practices, and the AI will actually follow them. This is how you prevent it from creating the kind of inconsistent code the study found. But it's not just about a config file. It's about how you work with the tool. You have to be a guide, not just someone barking orders. First, have the AI explore the code before it changes anything, so it understands the existing patterns. Then, break down big features into smaller, manageable chunks. Use those @ symbols to point it to the exact files and documentation it needs. And maybe the most important rule of all, you have to review every single change it makes, every diff. Trust it, but always verify. And look, this example says it all. A bad prompt is just fix the authentication. That's basically asking the AI to guess, and you're gonna get a mess. A good prompt is super specific. It says, hey, in this file, do this specific thing, then go to that file and handle the result in this specific way. You see the difference? You're not just a prompter, you're an architect. You're in control. So that really brings us to the big takeaway here. Tools like Cursor offer us this incredible speed and leverage, things we've never had before. But what this research clearly shows is that speed without discipline, well, it just creates complexity and chaos. And it leaves us with a really important question for all of us building software. The AI can give us speed, but who is responsible for the craft?